In this section, we're going to talk about the flyweight pattern. We use this pattern in applications where we have a large number of objects, and these objects take a significant amount of memory. With the flyweight pattern, we can reduce the amount of memory consumed by these objects. Let's talk about a real example. Let's say we're going to build a mobile app like Google Map. As part of rendering a map, we need to show various points of interest, such as cafes, restaurants, hospitals, schools, and so on. So let's add a new package called Flyweight. And in this package, we're going to add a new class called Point. This class represents a point of interest. Now, in this class, we should have attributes such as X and Y coordinates. That is where on the map we're going to render this point. We should also know the type of each point, which can be hospital, school, cafe, and so on. We also need to know the icon for each point. So all hospitals have a certain icon. So let's add a few fields: private integer X, private integer Y. Now, we need an enum to represent the type of each point. So let's add an enum. We call it point type. And here we can have types such as hospital, cafe, restaurant, and so on. All these items are constants. That is why I've typed them in uppercase, okay? So in our point class, we also need to know the type of each point type. And we also need to know the icon for each point. So private, let's represent each icon using a byte array. So we can read the icon from somewhere like the file system and store it in an array of bytes. Now let's create a constructor and initialize these fields. So generate constructor, and I'm going to select all these fields. Click OK. Beautiful. So here's our constructor. Now, every point should have a method called draw. So public void draw. With this method, we're going to add a point to our map. So for simplicity, I'm going to write a print statement, print line. Actually, let's change this to print f. With this, we can use a format string. Let me show you. So first we add a format string. Here we define placeholders for the values we want to render. So if we add %s, we can replace this with the value of a string. So here we want to render the type of this point. Then we want to type @ and we want to render the coordinates in parentheses. So parentheses, we type %d, that is a placeholder for a numeric value, comma, %d. So this is what we call a format string. Now we're going to replace each of these items with real values. So we add comma. We're going to replace %s with the type of this point. So type. Then we're going to replace the first %d with the x coordinate and the second %d with the y coordinate. Pretty straightforward, right? Now let's add a class for getting the list of points. So we're going to call this class point service. So here we need a method that returns a list of points. Let's import the list, and we call it get points. Now, in a real application, this method is going to call our backend to get the list of points that are stored in a database. In this demo, we don't want to worry about these details. We want to create a simple list and add one point to it. So let's declare a list of point called points and set it to a new array list. Now let's create a point. Our point equals new point. Here we should pass the x and y coordinate. Let's say 1 and 2. Next, we need to specify the type of this point. So point type dot cafe. And finally, we should pass a byte array that represents the icon for this point. In this demo, we don't want to worry about the actual rendering of an icon. So let's just pass no, it doesn't matter. So next we add this point to our list and finally return the list. Now we're going to use this method in our main class to get the list of points and render them. So let's go to our main method and create a point service, new point service. Here we're going to use a for loop. For each point in service that get points, we're going to call point.draw. Let's run the program. So we have one cafe at this coordinate. Beautiful. Now, let's say we build this application and deploy it. And later on, we figure out that on some mobile devices, it doesn't perform very well. Perhaps the application freezes or crashes because it runs out of memory. So we start investigating the problem. We figure out that this point class consumes a fair amount of memory. Now, in a real mapping application, we don't have a single point. We could have hundreds or thousands of points of interest. So that is the reason why on certain mobile devices with limited space, this application crashes. So in Java, an integer takes 4 bytes. 4 bytes. Here we also have 4 bytes. Enums also take 4 bytes. So another 4 bytes. Now let's say each icon takes 20 kilobytes of memory. So with this structure, each point object is going to take just over 20 kilobytes of memory. If we have 1,000 points to render, we're going to need 20 megabytes of space. That's a fair amount of memory for a mobile device. Not every mobile device is going to have 20 megabytes of free memory. Quite often, people don't close the apps that they open, so all these apps are running in the background and taking some amount of memory. This is where we use the flyweight pattern. With the flyweight pattern, we can reduce the amount of memory that our application uses. I'm going to show you how this works in the next video.